Hi everyone, and welcome to my presentation. My name is Arthur Carvalho, and I am a faculty member at Farmer School of Business, Miami University. So our work is about sentiment analysis. For our purposes, sentiment analysis will be techniques to estimate a writer's sentiment from written texts. So sentiment analysis draws from several fields like computational linguistics and statistics. As such, correctly developing and deploying effective sentiment analysis models can be very challenging. But one positive development in recent years have been the rise of off-the-shelf technologies for sentiment analysis. These are technologies offered by cloud platforms such as IBM Cloud or Amazon AWS, and they make the whole process of deriving sentiments from text incredibly easy. One should naturally expect that the accuracy of different techniques and technologies varies based on a series of factors. But the consequence here is that when one uses a single technology to estimate sentiment, the underlying result might not be robust. For example, if I use one specific technology, I can find that the sentiments are highly correlated with a certain variable, but if I use a completely different technology, I can find the opposite. So to mitigate this problem, the solution I offer in my paper is to use more than one technique or technology when you estimate sentiments behind texts. In other words, what I propose to solve the above problem is to use ensemble models. The specific research questions I'm interested in this paper are: number one, under which circumstances are ensembles of sentiment analysis models more accurate than the individual technologies or techniques that we use to create the ensembles? So number two, the other research question I'm interested in is which type of ensemble models are more accurate when we estimate sentiments? To answer these two research questions, I performed two studies involving social media data. The study number one involved tweets, short texts, and the study number two, Facebook posts or long texts. And to create the ensembles and answer the research question 1 and 2, I used three technologies. From IBM Cloud, I used natural language understanding. From Microsoft Azure, I used text analytics. And from Google Cloud, I used natural language. So let me say a few words now about the experimental setup. So the text in our data sets, tweets and Facebook posts, are not pre-processed at all. We take the texts as they are, and we send to these technologies and get the scores, the sentiment scores back. However, the sentiment scores here, they're not inside the same interval. So we normalize all the sentiment scores from these different technologies so that the scores are inside the interval -1 to +1. Now we create the ensembles in three different ways using the scores. The first, the most natural way, is to just take the average. We take the average of the scores, and that is what we call the average model. The second model, we perform a weighted average instead of a simple average. We assign the weight 0.5 to the most accurate individual technology in our study and 0.25 to the remaining technologies. And the third model is called the majority model. Here, we do not aggregate sentiment scores. Instead, we aggregate sentiment labels. So we take the individual scores, we translate the scores into labels. If the score is less than 0, it becomes the negative label. If it is greater than 0, positive. If it is equal to 0, it's going to be neutral. Now, the next step in our experiments is to translate these aggregate scores for the average and weighted average models into labels. But to make this translation, we take this interval from -1 to +1 and we split that interval into three pieces of equal size. For example, for the negative label, we take the aggregate score between -0.33 to -1. On the other hand, if it is between -0.33 and +0.33, we say it is neutral, otherwise we say it is positive. Now the reason we do that is because for both of our data sets, we have ground truth labels. we have labels provided by human beings. So what we can do now is to compare the labels for every single one of the ensemble models against the ones provided by human beings and see which model is the most accurate one. So let's discuss now our individual studies. Study number 1, Twitter, about short texts. This was a study about the problems major US airlines face. A total of 10,000 plus tweets were collected before a few years ago. You can see how these tweets are relatively short in nature, and for every single one of the tweets, we used Crowdflower, a crowdsourcing platform, to collect ground truth labels from crowd workers. So let's take a look at the results we have for this specific dataset. First, we look at the correlation between the individual scores on the Twitter dataset. If you look at these correlation values, you will see that they are quite high, and the same thing is true when we calculate the correlation for the labels. The problem now is when we try to build an ensemble and the individual models are highly correlated, the ensemble will not necessarily be that powerful. And that's actually true here in our results. Looking at individual technologies first, you can see how NLU is the most powerful individual technology. NLU is so much better than the other two technologies. When we just blindly average them together, it makes NLU and the final ensemble actually much worse. The only exception is when we take into account that NLU is the most accurate technology. When we take that into account and produce the weighted average model, we can actually do better than any of the individual technologies. But let's go to study number 2. The datasets came from a study where we collected data on Starbucks public page on Facebook. We collected a total of 3,000 plus Facebook posts. You can see how the average length and the maximum length of these posts are considerably greater than the posts on Twitter in our study number 1. Every single Facebook post was labeled by 5 crowd workers, and we defined ground truth labels. So let's take a look at the results for this specific data set. Again, looking at the correlation, the first thing you will notice here is that the correlation values are actually much lower than the correlation values for our study number 1. And the same thing is true when we look at the Spearman correlation. As a consequence, we have these models now a little bit more independent of each other, and when we try to aggregate them together, the overall ensemble will perform better than the individual technologies. You can see these results now in my screen, how both the average model and the weighted average model perform better than any of the individual technologies. So let's put all these results together now. So the main finding number 1 is that, yes, there is some correlation between sentiment scores and sentiment labels, and the degree of correlation is higher for short as opposed to long texts. The second main finding is that the ensembles of sentiment analysis technologies, they tend to be more accurate than individual technologies when estimating the sentiment of long texts. So putting these two main findings together here, what we have is this. For short texts, the individual technologies tend to do quite well because short texts are straight to the point and estimating the sentiments become easier than when we have long texts. So if all the technologies tend to do quite well, combining them together will not necessarily bring a lot of benefits. However, when we have long texts, it becomes more complex now to estimate the sentiments. These technologies tend to disagree with each other, and now combining them together will result in a better ensemble model. Now, going to the main finding number 3, ensemble models that rely on scores as opposed to sentiment labels perform better. Again, that makes sense because when we create labels, you throw away a lot of information. And finally, the weighted average approach is the only ensemble model we study that is consistently more accurate than the individual technologies and other ensembles. So in other words, if we have some information about the individual technologies, we should use that information when we create the ensembles. That's it for my presentation. Thank you for your attention.